Okay, guys, I hope you're able to hear my voice. My voice is not lagging this time. So last time in the OpenCV's first session, we learned about image transformation, important functions, reading images, rescaling them, some shapes, some putting text on that shapes, and some bitwise operations, right? Now we will move on with masking. Masking is like uh the further extension for this bitwise operation. We will see. So as usual, import your CV2 as CV. Okay, okay, there should be a space here. And then import numpy as np and take any image from your gallery or something and load it into image variable name. I am read. Let's take this copy relative path, put in here the address. And then cv dot and show uh art and also what is this image. And also don't forget to put this cv dot weight e and 0. Let's see if this runs first. Check. Okay, it's running. Great. So now what is masking? Masking means see this is a image, right? What if we only want this tower to be displayed and all the other surrounding to be black? We can do this by a method like we did in translation. If you had time to see that mini task 5, we had a question there in which you had to keep this tower and put everything else in the surrounding as black, but using the function translate. But here now we will use masking. Now what is masking? So before that, let's first create blank from our numpy np.zeros and image dot shape uh colon 2. What is this colon 2? The dimensions, height and the width. And we have to convert into data type, which is uint8 for images. We don't need to show this, so leave it. And then also there is now, see, what we did in earlier session in bitwise operations, we took this rectangle function and okay, wait, I changed this, I guess. This wasn't here. Copy. Okay, save. Yeah. So wait, huh. So what we did here is we were editing this blank image. That is, we were putting this rectangle on the blank image itself. So here we won't be doing this. Where is it? Masking, masking, masking. Okay. Yeah, masking. What we'll be doing there? We will be creating a blank copy. Now, what is blank copy? Let's see. cv dot im show. Let's put this as blank copy and blank, sorry, blank dot copy. Okay, now what is blank dot copy? It's just the same duplicate image of this blank with the same dimensions as image dot shape colon 2. Why we are using this? Because we want to create a different rectangle, not on blank, but on blank dot copy, but on different blank. So we will use here like circle, like let's do in circle. Circle is equals to cv dot circle. You'll understand why we are doing this. Just try to code with me now. Blank dot copy and let's put the now center, right? Let's put the center as the center of that image. So img dot shape. We learned this in the earlier session too, how to do this. Slash slash 2 comma image dot shape. Sorry, 0 slash slash 2. And also this should be in the brackets because this is a coordinate for um yeah. This is the coordinate for our center of the circle. Then we have to put some radius for our circle, which we put as, let's put 100. And now color, what color we have to choose? We will choose color as 225, that is white. Why choosing white? Because we have to mask this. I will explain you this later. Wait. Now let's code first and also create a rectangle function. Wait, before creating rectangle function, let's see what you have to do. Wait. So now we are going to mask it, right? Mask this image, our park image. So mask is equals to uh, mask is equals to cv dot. We are going to use bitwise operations here too. That's why I said this is the extension for our bitwise operated this file, bitwise.py. So yeah, now here what is this source one, source two, and we can see here mask, right? Mask mat light. So source one, source two is will be same when we are using masking. That is what image we have to mask. What image we have to mask? We have to mask the park image, which is img. So we'll put img in both sources and we'll put mask equals to this circle. Okay. And keep in mind, whatever the sources are, whatever this mask is, everyone should have the same dimensions or else it won't work. Okay. So let's mask this and let's show this first. I will show you cv.im show.
Comments.
Yeah. Yeah, what?
Comments for the code. No, like
Okay.
write comments explaining.
Okay. Okay. Is my voice lagging?
No, no.
Okay. 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 So see,
Sir, can you please
source
enable the chat?
enable the chat. Okay. You're not able to chat? Keshav?
No, sir.
Keshav?
Yeah, 100. Yeah, yeah.
Uh, enable the chat, bro. If you have doubts, just speak. You unmute yourself. He's enabling the chat. Here now source one and source two and also mask should have same dimensions. Should have same dimensions. Okay. See without this, we'll explain you what is mask and everything. Let me first show you the output. Okay, see guys, what happened. Our circle was, okay, let me show this circle too. Okay, cv.im show circle and circle. Saving this and running this again. Okay, so this is, let's cancel this. Okay, so this is a circle, right? The white circle. This is our image that we are putting in source. And this is our mask. Now, what is happening here? What is this? Source one, source two. What happens is bitwise and in source one and source two, they gets operated in an AND function, right? In an AND operator. What is this operator? Okay, wait. Huh, sorry. Hmm. What is this operator? This circle will go with ANDing with this. So the white portion will AND with this picture, and the black portion will and with this picture. Now, what is black? Black is 0 and white is 1, as I explained in the earlier session. So, what happens when you AND x and 0? It is 0 irrespective of what is x. Now, what happens if you AND x and 1? It will be x irrespective of what is x, right? Because x and 1 is x and x and 0 is 0. So same way, this white image and this, when you add this black portion will be black and the white portion will be the image itself, which we got here. So we have masked the tower using the mask function. Now let's do something else. Do you have doubts here? Wait, let me ask you. Okay, do you have doubts here, guys? Chat in the
The chat is
text in the
not
chat
available.
box. Chat is not
Wait, you guys
available.
can't
Okay.
use the chat.
I guess Radhe Shyam has texted. Yes, right. So I guess you are able to. Guys, try texting first. Try texting. Yes,
Yeah,
yes,
okay,
we can
maybe try
use.
leaving and rejoining if you're not able to use the chat.
Yeah. Try doing that because everyone is doing. So yeah, okay. Rectangle. Okay, if you have any doubts here, please chat, guys. Any doubts? Put a thumbs up or something like that. I'm waiting. Uh, okay, I hope so. I hope so. There are no doubts. Okay. So okay, rectangle. So we will create some rectangle. So we will use blank dot copy because we are not going to edit the original blank image, blank variable name. And here also we will put coordinates as okay 30 comma 30. What are these coordinates? These are diagonal entries, diagonal first point and diagonal second point. So 30 comma 30 and 370 comma 370, and we will put this as white because we have to mask it, right? That's why we are going to take this, and also we'll create some weird shape which is equals to. Now we will merge this. How will we merge this? Simply using cv.bitwise bitwise, and we will use circle here. We will use rectangle. Okay, wait. Hmm, rectangle. And now instead of mask equals to circle, I will use mask equals to weird. That is like whatever the weird shape is. I don't know what the shape is. And now let's see the output. Okay, this is the mask. Okay, we got a gibbous moon. We call this gibbous, I hope so, yeah. So see, what is this? This is a weird shape. This was actually white. When this was ANDed with this image, we got this image. So yeah, that's it about masking. It's about and ANDing with your white image with your current image. That's it. I hope this is clear. There's nothing in masking, though there will be a question in the mini task. So prepare for it. That's it. Now moving on. Okay. Any doubts here, guys? Any doubts? Put in chat box. No, yes, something like that. Okay. Any doubts, guys? Again, how to use a translate function in OpenCV? Any example which relates to translate function? Translate function explain this image transformation, right? This translate function. So it's the same translate function we have to use, but not now. We are using masking. So yeah, I could not get the dimensions of rectangle. Okay, dimensions of rectangle. And since see this is 30 comma 30. See if this is a rectangle, our screen is a rectangle, right? Top left corner and bottom right corner we are putting as coordinates 30 comma 30 and 370 comma 370. So this is the coordinates of rectangle. And why image and image in mask code? Okay, see, it's a good question actually. See, mask is equals to weird. Now here we can use mask equals to weird here also, right? Image comma mask and then close bracket. What I mean to say is, wait, let me write it. We could have used uh hmm, we could have used here instead of circle, I will put image. Instead of rectangle, I will put the weird shape, that is we are going to use it for mask. Actually, what is the logic here? The in this one, we are using three images: image, and mask. So image is first ANDed, and then it is ANDed with mask, but with a different property, which I will explain. Now, if we use this, we'll get an error. Why we will get an error? Tell, like, guys, write in chat box, why we get an error for this? I hope so. We should get an error. See, we got an error. Okay, let's not write in chat. I will explain you. See, what is here? Where arrays have same size and type. Same size and type. Now it means that this weird and this image doesn't have same dimensions. What is the dimension of this weird? It is, let's see, print np dot shape of weird, and also shift alt down arrow np dot shape of image. Let's see this first. Let's comment this out, or else it will create an error. And cancel this. See, shape of weird is 47, 640. Shape of image is 47, 640, 3. So we can't put both in the AND function because they don't have same dimensions. That's why we put this mask in this particular argument, which is mask, like mask equals to weird. What it does is it converts into 47, 640, 3, and then does the AND operator with the source 1 and source 2. Now, why we are keeping source 1 and source 2 as same image? Because if we don't use this, if we just put source 1, the function will give an error, the code will give an error saying that we have to mention source 2. But if we put source 2 as some different image of same dimensions, then there will be a collision of images and we won't get the masked operation. Either we can put the image or we can put a white image instead of image, because image like x is x and 1 is x. So you can either use image as source 2 or a white image as source 2. So I hope this is clear. Moving on to next topic. I guess this is clear, like masking is done. Moving on to color spaces. Okay, color channels first. Okay. So color channels. Keshav, if somebody has doubt in the chat box, do tell me. Import CV to CV, import numpy as np, and here also we are going to take, wait, where was masking? We'll copy this, put in the color channels code because we are going to use this, and here also we are going to create some blank is equals to np dot, okay, let's copy it from here only. It will be great. Where is it? Masking, copying this to color channels, pasting it here. And then now, what are color channels? We have three color channels, right? BGR. Now, what do you mean by BGR? BGR, we obviously studied blue, green, red. Now, this image, what we have here, let, okay, CV dot wait key, CV dot wait key. Don't forget this.
Karthik,
CV
can you just
dot
go back to the masking code and show it with the circle?
masking code and show it with a circle. Okay.
And is asking for a simple example.
Okay, circle. So this is circle. And wait, everything is okay. CV dot. Okay. Yeah. Wait, what is the problem? Weird. Okay, I will have to comment this out. Control is run. Okay, see, this is a circle we have created that is white inside because we used -1. That means it is white inside also. And we are adding this with the image input. What this is spark image, right? So we are adding this circle with this image and we are getting this. So I guess this is done. This is what he was asking, whatever, who was asking this? Okay, see, I just created a circle using 225 or 250. Okay, whatever you can use here. 225 I used -1 here to completely fill the circle with white. And then I used mask equals to circle here to get that following output. Yeah, okay. Moving on, color channels. Okay, what are color channels? So let's run this. We have BGR, right? Blue, green, red here. Only with blue, green, red, we can express the entire image. So what if I wanted to divide this image into blue, green, and red separately? For that, we will use some function known as split. So B, G, R equals to CV dot split. And what split we are going to do? We are splitting this image, this spark image. And we will show this first. Okay, before showing this, let's see the shape of this. Shape is important. Before writing this, okay, let's write this and I'll ask you. Shape of B. See if I am not running this. Tell me guys, what is the shape of this? What will the answer? Print np dot shape of B. We're splitting this three colored channel into BGR. And let's suppose, okay, I will have to get this also, right? Okay, wait. Print this shift or and np dot shape image. Run this. Okay, see. This image has a shape of 427, 640, 3. So what should be the shape for np dot shape B? Like what is the shape of B? What is the shape of G? What is the shape of R? Type in a chat box. Type in a chat box. Don't run it on your code, guys. Try to think and then tell the shape of B. Because I'm splitting this into three, right? It will be like too obvious to answer. What is it? 427 split into three parts. I think same. Okay. No, guys, this is not same. We're splitting this into BGR. That is, now in this B, we only have one quantity, that is blue. It is either blue or not blue. It is between this, right? It is between 0 and 255 of blue. That is, we only have one color channel for B, we only have one color channel for G, we only have one color channel for R. Okay, so let's run this and I will show you. Control S and save. See, it is 427, 640, which is like 427, 640, 1. That is, we only have one color, we only have one channel here, not the three channels. So wait, I will show you this cv.im show. cv.im show and take it as blue, give this as blue. And remember guys, write in BGR, BGR format because OpenCV supports BGR format, not RGB format. So first blue, then green, then red. And let's save this and run. See, what is this? Black and white. Why black and white? Because this is only one color channel. This is either black, blue or not blue. And between those. So see, this is a light image, right? The white image. That means the intensity of blue in this lighter image, in the lighter section, is more. And in this dark section, it is least. See here, in this image, the park image. This is blue, the sky is blue, right? That's why we are getting a lighter image here. And here we don't have some essence of blue pixels here. That's why we are getting black, darker regions here. That means whatever is light, we have higher intensity of that color. Same with, okay, let's copy, shift, alt, and down arrow. Green, sorry, green, BGR, red, G, control and save and run. Okay, wait, let me. keep it right. This is blue and this is our image. Okay, see, this is blue, I guess. Huh, this is blue. What is this? This is red and this is green. Okay, see here. What is the lighter region you can see here? The tower. Tower is white. We are getting that is the intensity of red pixels in this tower is more. As we can see here, this is kind of red. See this tree, this tree, this tree, this tree. They are kind of reddish. That's why we are getting this trees, this lighter regions. This building is lighter. That means it should have more components of red in it. That is, we are getting this building as somewhat red. See in green. In green, you won't see that much because, like, okay, this is green, right? The ground is green, and we are getting lighter image than this. See here, this is dark and this is light. It shows that green is more in this grass than blue. What is this? Blue. So got it right. Whatever the lighter region is, it will have a higher intensity of that color. So I guess this is clear, and your doubt that is creating blank. Getting adjustment clip which we are overlapping to. I'm doing all the experiments on black image. Creating a blank image with an adjustment clip. I don't understand. Could you please elaborate? Okay, Keshav is having a doubt. See, also for the
Not,
first doubt.
not for you, for current.
Okay, Karen. Okay, I thought you were asking me. Okay, sorry. Uh, so yeah, I think it's clear. Well, see guys, again see the difference. Lighter region is having the more intensity of this color. Darker regions are having less intensity of this color. This is blue, so this is having greater intensity than darker regions. That's it. Okay, now let's do something else in this. Now we can see the shape of B is 427, 640, right? Now let's try to combine it with some black images. Okay, some blank images, not black. So blue is equals to CV dot merge. We'll explain what is this function and everything. Just type like code with me and then see what is this sequence mat like. What is this mat like? I would like see B and blank blank. Let's run this and see cv dot im show. Uh, this is actually what we are doing is we are imprinting blue and on a blank image. So blue. What is? Oh, cancel this. Cancel this. Wait. Cancel this. Okay. So what is this? In short, what I did is I combined blue, blank, and blank. If I combine BGR, I will get the exact same image, that is this image, the park image. But now what I'm doing is I'm removing green and red from that image. That is, after removing green and red from that image, I'm getting this. That means this is having blue and this sections are not having blue, but some other color. It can be green, it can be red. Because I have removed green and red, I can't say. So let's run on all three. This should be blue, this should be green, and this is red. Now, here, see the priority too. I can't put in the first argument itself BGR. G will be in the middle because it's BGR. G and blank, cancel this or control S and run. So, okay, sorry. I didn't show this, right? Hmm. We have to show this also. Blue imprint, green imprint, and red imprint. What is this blue? It's green. What is this blue? This is red. And let's comment this out. Control S and run. So see guys, Actually, you won't get here like what is happening here actually. It feels like you have painted the entire color with green, you have painted the entire color with blue and red, but it's somewhat different if you observe closely. Darker regions means there is no blue, and this region means it has a considerable amount of blue. Same with red. You can see here. See, actually, you can't see actually. See, we have just done what we have. Green imprint means we have removed blue and red. Blue imprint means we have removed green and red from the image, and red imprint means we have removed green and blue. So that's it. Now let's try to merge everything. Like uh, copy, copy image is equals to cv dot merge bgr. Now let's combine bgr and also show this copy copy image. The variable name is okay, I guess. Copy image. Copy image. See, what we have done is here now, we're merging BGR, this BGR, BGR, this one, split one. And each of them has a shape of 427, 640. When we are merging it in this copy image, we are getting three channels, that is BGR. And I guess it should be the same image. And see, copy image is same, exactly same as Spark because we are merging it like that. What will happen if I merge it like I put here red and I put here blue? Now let's predict like what will happen. We have interchanged R and blue. That means the sky was blue. Now the sky will be red. The buildings were like of well, buildings were red, I guess. Huh? The buildings were red. So now the buildings will be blue. And we will see here, see, green is almost same. But if you see the sky was blue, now it's red. This building was red, this tree was red, now it's blue. This building was blue, now it's red. That is, we are changing this. So make sure you write this perfectly. It's not RGB, it's BGR. I guess this is clear till here. And yeah, that's it for this. Are there any doubts here, guys? Using this function, we can use color gradient. Okay, any doubts here, guys? Reply with thumbs up, no, yes, something like that. It's saying merge takes max of two arguments. Okay, guys, don't forget this, huh? This square bracket. We're using square bracket inside the this parenthesis. Inside the square bracket, we are writing b comma blank comma blank. So make sure do that. And can we adjust the intensity like 50 or 60%? Okay. Adjust the intensity 50 or 60%. What do you mean by intensity? We are not using intensity here. Okay. Clarify it, Karan. What do you mean by intensity? Okay, so let's move forward. Don't forget the square brackets, guys. Square brackets means it's an entire one argument. Okay. Moving on to color spaces. I don't think I'm going first. It's kind of normal space. So yeah, import CV to CV, import numpy as NP, and okay, let's take the image. We'll take this image for now. Okay, we took park image, right? We can take the IITM image now. Copy relative path. Cancel this. We don't want this. Okay. Image is equals to cv dot im read and copy the path here. Put in single quotes. Sorry, single quotes and uh, cv dot im show What is this? IITM, sorry, M, IMG. Also, don't forget this CV dot wait key, 0. Control and save and run. So yeah, it's running. Okay. Now we're moving to color spaces. What do you mean by color spaces? I explained the BGR, right? BGR format. Now I explained also RGB format. In some applications, in some library, like Matplotlib, we use RGB format. Now, what is this BGR, RGB? Also, we also have something called HSV. What is HSV? Okay, let me write here. HSV stands for hue, saturation, and V is for uh wait, wait. HSV, right? Use, huh? What? Okay, somebody said something about V. Okay, V something. Okay, I forgot what is V. Okay, V something like intensity. Wait, I will search what is V. Sorry, HSV. Color cone.
Vibrance, I guess.
Yeah, what is it? Value. Okay, okay. V was value. Shit. Damn. Okay, sorry. Yeah, so this is HSV, U saturation value. Now, what is U? What is saturation? What is value? Let me show you one thing. Uh, HSV cone. HSV cone. See this, guys. I hope you're able to see my screen. Keshav, are you able to see my screen? This one?
Yeah.
Okay. So this is U. U means angle. So as we said in BGR, RGB, we determine images by just colors, that is red, green, and blue. But in HSV, we used angle, that is U, saturation, that is what it should be. Like what saturation? Light blue, dark blue, ocean blue, river blue, whatever, sky blue, whatever, right? This is saturation. And what is value? It is intensity. Should it be kind of black or white? What it should be. So this is what hue saturation value is. Whatever image it is, you have to know three values of it, three features of it. That should be independent. Now, as you see, RGB are independent of each other. Same way, hue, saturation, and value are independent of each other. Now, angle doesn't depend on saturation, saturation doesn't depend on value, and value doesn't depend on hue and saturation. So, HSV is kind of thing we use for like we say like HSV is used for is similar to human perception. Okay, not he man, human. Similar to human perception. We don't perceive images through RGB and BRG values in our brain. We perceive it through this hue, saturation, and value. Okay, so what are we doing here in HSV here? We're going to convert this BGR format into HSV format. So let's see how to do that. Write HSV variable name is equals to CV dot CVT color. Color spelling is American spelling, not the British spelling. So COLOR and then CV dot color. We have to convert this image into CV dot color. Now see, there are many things to do. BG to BGR. Okay, this is not what I want. Okay, leave it. Color BGR2 HSV. What is this? BGR to HSV. We are converting this BGR image to HSV image. Now let's show this and run CV CV dot CV dot I am show HSV HSV. This is how we humans perceive image. Control S and save. Okay, yeah. See, this is how we perceive image. I guess we have seen in movies or some kind of things like we have some specs in night and some night vision thing looks like this. So it's kind of similar to this. So yeah, we have here in this BGR, we determine image through BGR. In HSV, we determine image through HSV, use, saturation, and value. So I guess this is clear. Any doubts? Type in the chat. I will see once this is completed. Now, what is LAB? Wait, let me write this first. CVT, color, um, IMG. What is this? CV. Okay, huh. It's CV dot COLOR. Now it should be, what should it be? It should be BGR2 LAB. That's it. It's exactly same, like almost same. Shift or down arrow or down arrow LAB LAB. Though LAB is not used now, it was used in the earlier times when HSV was not there. Now we have HSV, so we don't use LAB. Now, what is LAB? As we saw here, this is BGR, all three color channels, right? In HSV, no color channels, it is hue, saturation, and value. But in LAB, we have L means something known as brightness, intensity, uh, saturation, kind of saturation thing, like light blue, dark blue, like that. Okay. And what is A and B? A and B can be any two colors, right? Like red and green, blue and green, red and blue, whatever. So it is generally expressed as L star, A star, B star. Why? There is a specific notation for it. If you search on Google, you will get it. Like here in BGR, we used three color channels. In HSV, we used no color channels, just HS, we used saturation value. In LEB, we used two color channels and intensity. So yeah, that's it about this. And there's also some function to convert into RGB. Like RGB is equals to CV dot CVT color and IMG. Like this is I'm now writing for converting BGR image to RGB image. So image CV dot, and you have guessed it right actually. There's nothing else. CV dot color underscore BGR2 RGB. That's it. Shift all down arrow. And here we have our RGB value. Like I don't have to explain this actually, but still I'm writing. Okay. See, this is our RGB. Okay, run this page. Hmm. This is our RGB. This is our BGR. That's it. Okay. So it's done. Color spaces are done. I hope there are no doubts in color spaces. Okay, where is the teams? Special. Okay. Are there any glasses? Oh, sorry. Are there any doubts, guys? Is any doubts in this HSV, human perseverance? Okay, not a human, sorry, human perception, LAB using only two color channels, and RGB to BGR is okay. Any doubts, guys? Comment. No doubts. I have doubts. Like red is increased to 50% or green is increased to 30%. Okay, can you show example? I don't see. I don't
You know,
see in
I
HSV, I
sent
guess.
I sent the theory for this above. I'll send it again.
Yeah, okay, okay. I don't see in HSV, I guess. Okay, guys, we see in HSV, but our brain perceives it in the RGB format later. But actually, it perceives in HSV, sorry. Still, nobody is able to like guess what is happening in our brain till now. Funny question, why are we calling this color spaces? Okay, Color space is, I guess, it is because of coordinate system. Because in coordinate system we have x, y, z coordinates, right? Three factors x, y, z. It creates a space. And else in colors we have BGR, x, y, z coordinate, BGR. So it creates a color space. That's it. It's not a logic. I'm just saying like that. Okay. Now let's create another file, blurring.py. Blurring. Now we will learn about some different techniques of blurring. Earlier, what we did was it was Gaussian blur. We will see more blurs, what methods we have, and how does it implement. Import CV to CV, and we don't need NumPy for this. So okay, image equals to CV dot im read. Oh, again, comma, sorry, im read, and then what what image to take? Like look a new image actually. I have a new image. Should I take that image? Okay, wait, I will take a new image. Oh, where is it? Documents. Oh, my PC. My PC downloads group to no desktop. Okay, I guess I can take this. Copy path. Take the dear image. Paste it here. Sorry, paste it here. Put R before it because we are using it as raw. We're taking complete. That's why. And cv dot im show. It's dears. It's not dears and emg and cv dot weight key 0. Okay, let's see how. Oh, this is too small. Damn. Okay, we are not using this. Leave it. We're using this copy relative path. All time waste. Sorry. Remove this art. Ah, so this is we are getting. Okay. Any doubts here? No, right? Okay. So, blurring techniques. So, what are blurring techniques we have? First blurring technique we are going to see is average blurring. What is average blurring? Average is equals to CV dot blur, best blur. That's it. Sorry, CV dot blur img, comma. Now the kernel size. What is the kernel size? I explained it earlier also. 3 comma 3. I will explain it now in detail actually. CV dot im show blur average. Sorry, average, average. Let's run this and see what is it. See, it's kind of blurred, right? It's little blurred. If we increase the kernel size, then the blur will increase. Now, why is this happening? How is this happening actually? Imagine a 3 cross 3 matrix, right? Like 3 cross 3 squares, 9 squares in it, right? So, what we do here is now we are using 3 cross 3 kernel size. That means 3 cross 3 squares, 9 squares. We calculate the middle square on its surrounding squares, on the intensities of the surrounding squares. Let me first search like 3 cross 3 squares template. Yeah, perfect. See, this is 3 cross 3 kernel size. Okay. So if we want to calculate, we calculate the middle pixel always. We always have 3 cross 3, 5 cross 5, 7 cross 7. Why? Because we need a central pixel. For to get to central pixel, we need odd values, right? If we get 4 cross 4, we won't get a central square. So now calculate the intensity of the central square. What we do in average is we take the pixel values of this. Oh, sorry. Huh. We take the pixel values of all these 8 squares surrounding the middle square and average the intensities of that. Like imagine this has 67 value, this has 150 value, this has 135 value. And what is this value? This is intensity of that pixel. How much intense is that pixel? So this is 52, this is 46. We will average this all and put in the middle image to get the average. That's all we are doing in average. That's it. Like I will write it here. Averaging the surrounding pixels, I should say. Pixels, right? Surrounding pixels to get the middle value of that pixel. Okay, of the middle pixel actually. Huh. Now let's see some different one that we used earlier also, that is Gauss. Okay, is there any doubt in average blurring? Are there any doubts? Okay, can you repeat the last 2 minutes? My Wi-Fi got disconnected. Okay, last 2 minutes. 51. Okay, last 2 minutes. Okay, I only explained this average part. That is this part. To get this middle image, a middle pixel, we average the intensities of the surrounding pixels. Like A plus B plus C plus D plus E plus F plus G upon 8 to get this. This is average blurring. Any doubts here, guys? I hope so not. Nobody's replying. So yeah. Okay, we'll move forward. Gauss is equal to CV dot Gaussian. CV dot Gaussian blur. And here we have image and what is this? Kernel size. Kernel size we are putting as 3 comma 3 and that's it. I guess we
Karthik,
don't need more.
Pawan has asked for last 2 minutes. Repeat
What?
it. Pawan has asked to repeat the last few minutes.
Okay, in last 2 minutes I did nothing, bro. I only just did this average function. What is this average function? What is this blur function? Simple blur, average blur. It does this. What it does is like it calculates the middle pixel on its surrounding pixels. Like in this image, we have 8 pixels, right? So we take the average of this 8 pixels and put it in this middle pixel, and we get the average function of that particular image by moving this kernel size all over the image, all over the window. That's it what we are doing. 3 comma 3. In case of 5 comma 5, we will have 5 squares in the up row. We have 5 squares in the down column and everything 5 5 5. And then we will take the average of every 24 squares and we will put it in the middle 25th square. That's it. If we use here 5 cross 5, we will get a enhanced blur actually. Like too much blur we will get. Okay. I suppose there is some problem. Okay, I guess here I should put 0. Hmm. So see, there is more blur than 3 cross 3. When we increase kernel size, we increase the blurring. That's it. Okay, why did I use 0 here? What is this? See, kernel size, the source mat like sigma x float. Now, what is this sigma x float? This means that, uh, what is this Gaussian blur first? Gaussian blur states that we have this size, right? We used average, normal average, like A plus B plus C upon 3. Now, Gaussian blur is weighted average. What is weighted average? I hope so you know what is weighted average. We put some weights to the squares. Like put this as 5, this as 3, and this as 2. So 5a plus 3b plus 2c upon 10. So this is Gaussian blur. I can show you, uh, wait, I can show you this thing. The OpenCV documentation for this Gaussian blur. OpenCV documentation. I hope so. Can see that. Wait, 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 wait. Hmm. See this, guys. Gaussian blur. We specify this. See, Gaussian blur is highly effective in removing the Gaussian noise from an image. Why? Because we are putting some weights to this. We're putting some weights to the squares. And then we are taking the average, not like the simple average blur. And what is sigma x? Sigma x is the deviation in the x and y direction, sigma x and sigma y. We can either specify sigma x or sigma y, or else the function won't like, there will be an error if we don't put the sigma x or sigma y. See, if sigma x is specified, only then sigma y is taken as sigma x. If both are given as zeros, they are calculated from the kernel size. If we don't put anything, it will be like average blurring. So yeah, this is what Gaussian blur is. Now cv.im show, I will show you what is the difference between average and Gaussian. Gaussian blur. What is this? Gaussian, Gaussian, moving on. This is Gaussian blur. Okay, wait. Let me put this as 5 comma 5. 5 comma 5. Hmm. See this Gaussian blur. It's somewhat different, right? If you can see. I hope so you can see. Wait. What is the difference? Okay, like the blur average is greater average than Gaussian blur. Also, the Gaussian blur somewhat preserves this outlines. See, you can't see the outline of the building here, right? With the same kernel window. This is 5 cross 5. This is also 5 cross 5. But you can't see the outline of this building. But here you can see the outline just because we're using Gaussian blur, which uses like weighted average. So, yeah, that's it about Gaussian blur. Just wait for 2 minutes, guys. I will join you. I will continue this. Just Keshav, I will come in 2 minutes, huh?
Yeah, okay.
Yeah. Okay. Sorry. Sorry, guys. Was we out of the 2 minutes? What is this? Interesting. Nice. Can you please re-explain Gaussian blur part? Okay. See, I think you missed this part. Sigma x and sigma y. See, what is the sigma x, sigma y? If I put as 0, put this as 1. Let me try. Hmm. So actually, what is the sigma x, sigma y? This is the deviation across x-axis and y-axis. If I put 0, this is along the x-axis. If I put 1, this will be along the y direction, the standard deviation. Now, what does it mean? You have to see into the algorithm of that Gaussian. I won't explain the algorithm of that Gaussian blur. See in the OpenCV documentation and you will get it. if you want to go in deep. Also, there is now we have more blurring techniques. Median median is equals to CV dot wait, it's too hot. Huh. Okay, median is equals to CV dot median blur and okay, we have capital B LUR and then median blur. We have to put here image and we have to put here the kernel size. What kernel size you are going to use? We can either put 3 comma 3 and put like CV dot IM show sorry median median we this should be like this. This should be this. Huh. And if we run this, we'll see. Oh, why it's loading. Put this 3. Okay, done. Okay, see guys, here also there is something we can see. See here, case size. Here they are asking case size. Here also they are asking something like case size, I guess. And here they are asking case size in. So what does this mean? Like we can't put 5 comma 5, 5 comma 5 or 3 comma 3. We have to put only an integer that is 3. It will automatically see it as 3 comma 3. So if I put here as 5, it will see it as 5 comma 5. And then it will give the median blur. Now see, this is kind of interesting. In blurred image, the blur average, you can see the tower is not completely visible. But now see, the outlines are more kind of distinguished. See, the blur is almost the same for the middle part, but see the outline of this building and see the outline of this building. See the outline for this tower and see the outline for this tower. Now this blur is more like the intelligent blur kind of thing, right? But why is this? Because what happens in median blur is we have 3 cross 3 squares, right? We cancel that window. So yeah, imagine that we have 3 cross 3, like 1, 2, 3, 4, 5, 6, 7, 8, 9. We are calculating the middle one. We will take the surrounding values of the pixels, like surrounding intensities of the surrounding pixels, and we will take the median of it. What is median? Median, like if we have 5 numbers, 1, 3, 5, 3, 4, then we will put this in increasing format. We will first put this in increasing format like this. Now, what is the median of this? The median is 3 because it's the middle of the sequence. So in the average, we did the average of that 8 squares and put in the middle one. We in the Gaussian, we took the average, we took the weighted average and put it in the middle one. And here in the median, we are taking the median of that 8 squares and putting it in the middle one. So yeah, that's it. And that's why we're getting a nice outlined blurred image. See this outline. This tower is standing out in the image. Oh, sorry. Hmm. Moving on, we have something called bilateral. Okay, we have something called bilateral blurring. It's not bilateral blurring actually. It's like bilateral filter. Bilateral filter. What is this bilateral filter? I'm just introducing this to you. I'm not explaining this. This is actually a more greater knowledgeable version of this Gaussian blur, which we see here. We have some arguments here. Just put this arguments. Actually, I don't want to introduce this, but still, okay, I have time. So yeah, I am cv.im show. Let's put this as bilateral, sorry, bilateral and bilateral. And let's see. Okay. CV CV2 has no bilateral filter. What? Wait, wait. Sorry. Huh. Okay. The B is small. See, in bilateral filter, we don't see any filter averaging. Okay. Wait. See this image and see this image. Can you see some difference? Uh, I don't think we can see any difference in this. Okay, see, actually, this is many arguments. We have many arguments here, like math, like this D and sigma color, sigma space, distance, border type, and everything. If we specify each and every argument, then we can get a perfect blur that the user wants. So this we will keep out of the syllabus for now. But do search on this. If you have curiosity, search on Google and try to understand what are the arguments. How should I put this? How each an argument depends and factors affects the blurring, right? So keep this bilateral as a homework for you guys. Okay, I guess this is understood. There are no doubts for here. There are no doubts, right? I'm just executing 3 minutes. CV is not defined. Import CV as CV. Okay. Karthik, don't panic. Take deep breath and teach. Okay, sorry, bro. It's too hot. I can't help. Okay. Hmm. Blurring. Okay, so next topic we are taking now. Sorry if I was teaching you very fast or something like that. We will move on. Contours underscore edge dot py. Import CV2 as CV and also import numpy as np. Do make sure you write import CV2 as CV. If only you do import CV2, then you can't uh, call the libraries as cv.gaussian blur or cv.average blur or whatever. Then you will have to write cv2.gaussian blur, cv2.blur like that. I'm writing this as cv because of it. I don't want to write 2 every time. That's it. So write image is equals to cv.imread and copy this IITN image, I guess, and copy where is copy path, copy relative path, and put here this thing, then cv dot im show um iitm img cv dot wait p and 0. I guess this is working.
Okay.
Hello, is anybody trying to say, bro? Who is this? Okay, no problem. A little bit fast, but interesting. What are this 10, 35, 25? See, these are the arguments. There are actually 5 to 6 arguments in that. What was that? Bilateral filter. So, yeah, I won't explain that actually. Like, it's too complex. So, you have to see its algorithms and everything, and then you have to understand and why. Like, you can take the help of Google, ChatGPT, and everything. You can understand that. Okay, fast. I won't go so fast. Okay. So, now we'll see what is contours and edge detection. We in the previous session, I hope that we did some canny detection, right? See this canny. What is this canny actually? This okay, I will write this here. Contours and edge.py. Okay. What is this canny used for? This canny is used for edge detection. Edge detection, or I should say edge edge preserving, okay, edge showing or something like that. Yeah. So, is anybody trying to say, bro? Or else unmute your mic or mute your mic. Yeah. Can is used for edge detection in an image, in an still image, I should say, in an still image, not a moving image, not a video, in a still image. But what is contour? Sorry. What is contour? Contours are just like edges, but they are more in continuous fashion, or you can say like a continuous, like a loop kind of thing, or loop, sorry, loop. So in edges, you can have some random edges, but in contours, you have some loop or you have some continuous fashion. The edges are some like in a closed loop. I should write closed loop. Actually, there is a very minute difference in contours and canny, and it also depends on the image itself. Is your image that fine, which can differentiate canny and contours? I will explain this through your functions first. Canny is equals to, okay, let's copy it from, oh, is there a problem? Ah, no. Let's copy this from this important function.py, copy this and paste. Wait. Contours x.py. Paste here. Huh. So can is equal to c dot can amg. Our aperture size is 3 and this is this. Okay. So this is canny. Control S and save. See, you can see the outlines, right? These are the outlines. Oh, sorry. Hmm. These are the outlines of this image. If you want to decrease the outlines, what you can do is you can do something called blur, which we learned just now. Blur is equals to CV dot, yes, let's use Gaussian blur, kind of like Gaussian blur, and put this image here and put the kernel size as 3 comma 3 and keep this as CV dot border. What is this border default? And this, it is like, this also makes a very small difference actually. There is some border default, wait, I will show you. Border default, border reflect, border constant, isolated. There are many borders. Each one have their like some of their characteristics in itself, like reflect. Actually, what it reflect does is you have some window type, right? You have a outline for that window. But inside that window too, if you have some outlines, it will show you the reflect part. But what is default? Default will just show you the outline of that window. It won't show you the inside part of that window. And in normal case, we always use default if we don't have any idea how to use that blur for the user kind of thing, right? If it's not specific, we will use border.default, like border underscore default. And we will put here Canny's input as blur. Why? We will see later. Like we will see now. We will see the results. See the image, see the outlines are reduced, right? Okay, let's compare this. Shift or down arrow, alt down arrow. I will use here as img input. I will use here canny underscore img and this as canny underscore blur and canny underscore img, canny underscore blur. Again, too much work. Blur Kenny underscore img. Okay, let's run this and see. See, this is the blurred input I gave, and this is the original input I gave. Which input, like, which borders you think is good? This one, right? I guess this one. Because you can see the grass outlines are gone because of blur. You can see the girl properly. You can. see the lamppost. You don't see this kind of thing on the road. The road is also clear. You can see the road perfectly. Also, you can see the entrance here. Something is present here, but now it is not here. Why? Because of blur. What blur does is it removes the insignificant outlines and only like shows the significant outlines, the dominant outlines, because of which we get less outlines in the blurred image. Now, what is contours? Hmm, what is contours? So let's write first. We'll explain everything. Hierarchy. Hierarchy. Hierarchies. I think the spelling is right. So contours dot hierarchies cv dot find contours. Okay, find contours, and we will put here img cv dot retr underscore. Now see here also we have something like ccom external flood fill list. Now what are these contours? Contours, as I show, as I wrote here, contours are just like edges, but they are more in continuous fashion or closed loop. But it's not normally not seen in our type of images. They are like very fine images. We will see the difference between contours and edges. Now, what is this list? What is this list means? Like return list means we are taking all the contours in that image and storing it in the contours variable name. What is this external? That means it will only take the external contours of that image, of that particular objects in the image. If we have a cat, it will only take the external outline of that cat and store it in the contours. But now we will use retter list, which means it will take all the contours and store it in this contour variable name. Now, what is this contours variable name? What is the type of it? The type is list. The contours are producing some lines kind of thing, the coordinates, and it will save the coordinates in form of lines in this variable name contours. What is this hierarchy? We won't be teaching hierarchy in this session. Hierarchies is something which this function returns. Hierarchy, actually contour uses hierarchies to show this one. Wait, there is retter list hierarchical. Wait, hierarchical, something like that. Okay. Hierar- We also have this RETR and hierarchical. Now, what is this? This is actually using these hierarchies and producing the contours. But we are not taking this into consideration right now. We'll just create this list for now and we will print this. Now, as this contours is list, we will see how many contours are present in our um, image. So let's see how many contours are present in our image. Uh, F, what is it? F and sorry, what was it? F, how to print statement? Huh, okay. Alien and contours. Contours, and then after this pink one, I will write R the number of contours in this image. Let's print this and run if this is okay. Ah, okay, huh, okay. I'm missing something. This is also like CV dot chain approx none. Now what is this? Approx none, approx simple. We have two kind of things. I don't know about this. Okay. Approx simple and approx none. So what is approx none? Whatever contours we get, should we place all the contours in that contours variable name, or should I approx them and then reduce them and then put in the contours? So we will use first chain approx none. That is, don't reduce it. Put in the contours variable name directly. Let's save this and run. Okay. Again, something is wrong. Wait, 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 wait. Sorry, guys. What is it saying? Expected CV type CV dot ATUC1. The image type is okay. Oh, okay. Sorry, sorry, sorry. We have to use here Canny as an input. Why? I will tell you. Wait. Canny dot image. Canny underscore blur we will use. No. ID underscore image. Doesn't matter actually, but okay. ID underscore image we will use, and now I think they will. Okay. Oh. See, this is Canny underscore image. This is okay, leave that. See, 1351. See here in the terminal section. 1351 are the number of contours in this image. Now, these are the closed loops that we are able to see, that the computer is able to see in the image. Now, what if I remove this none and put simple in it, like control save, sorry, control save and chain approx simple. Hmm. 1351. Okay, the number of contours are same. Oh, sorry. Huh. So see, 1351. Okay, so this makes no sense, I guess. Simple none for our image, actually. If it's a particularly fine image, then it will make some sense. Okay, let's use something else. Okay, wait, wait, wait. Huh. Let's use blur here because blur had less canny edges, right? So I guess this will be reduced. Yes, see. Here now we are having 360 are the number of contours in these images. Earlier we had 1351 are the number of contours. Now we have 360. Why this happened? Because we are using blur in this canny and then we're using this canny blur in this input. That is, we are removing some contours that were insignificant. And I hope you are getting some doubts in this. Okay. Uh, if string. Sorry. There are no doubts, guys, for this contours. Like there should be actually, because this contours is a confusing topic. Even with blur as well, it is returning same value for any type of it. Returning same value. No, it's not returning same value, right? Canny underscore blur gave 360 and Canny underscore image gave 1351. So the number is decreased now for blur because blur removes the insignificant counters. Now wait, let me show you this, how this contours look like. CV dot draw contours blank uh contours. What I'm doing now, I'm taking this contours and putting it on the blank image. I guess we have created blank. Okay, we haven't created blank. Okay, so blank is equals to np dot zeros and img dot shape uh oh img dot shape data type is equals to uint8. Okay, I've created the blank now. Now blank contours -1 we have to use 0. Why? Because it's contour index. We were taking contour index -1. Wait, wait, wait. I will explain this everything. 255. What is this BGR? We're taking it as red. Okay. And then thickness. What thickness we can take? We can take thickness as 1. And we can now cv dot im show this. cv dot im show contours blank. Why blank? Because we are not using blank dot copy, right? We are editing the blank image itself. That's why I'm taking here the input as blank. And I will show you what contour looks like. Let me comment this out. That's it. We're taking contours blur as input and see. These are the contours that we get. As you can see, most of them are like closed loops. There are some which are like straight lines, like there are lines, but see, most of them are loops. Most of them are loops. So yeah, this is contours. These are the 360 number of contours that the system has detected in this image. And we are producing it here. Any doubts here, guys? Where is Teams? Oh, okay, wait. What is this? What did she
I hear
say?
it out. I am going through it.
Okay, no problem. Okay. How can I store in blank? See, I'm not storing it in blank. What I'm doing is, what I'm doing is I'm taking this contours. This is actually a list of loops that I am having, list of coordinates that I'm having. And I'm pressing this coordinates on this blank image in the color of red. Got it right? And now I'm expressing it in an image called blank, which is now this is I'm getting right. This is the red, and these are the coordinates that are joined by lines. This is what CV dot draw contours does, this function, right? Okay. There's something more actually, like, but threshold is also there's something. Okay, I will explain you this. After this, we will go to face detection. RET thresh CV dot threshold. We will use here. Actually, we for this threshold, we first need to introduce gray image to this. So let's introduce a gray image. To introduce a gray image, we will write cv dot cvt color as we did in the earlier file and img and what are the next cv dot color underscore bgr to color. Oh, sorry, to gray. Check this pad. Okay, so this is two. So yeah, I created a gray variable name in that like the image is gray. And then in here, I will put here the input as gray and then the threshold values as 125, 175 as usual. And then we have here something called cv dot thresh underscore binary. Now, what is this? See, what this does is, uh, okay, this is very similar to something we did earlier. Okay, see, this what is this 120? Okay, here see 150 we have threshold 1. We have here threshold 2, 200. Actually, what it does is then whatever pixels we have between 150 and 200, it will consider as a outline. If it is below 150, it will neglect it. Same way, here in threshold, if amount of pixels, not the outlines, any pixel is between 125 and 175, then only it will keep it like dominant. Otherwise, it will keep it as black. If it's 125 and 175, it will keep it white. Or if it is below 125, it will keep it as black. So let me show you. Save it dot. I am sure. Uh, Thresh, and this is again Thresh. Uh, Control and save. And run this. See, this is a threshold image that we are getting. What is this doing? This is actually converting the pixels that are between 125 and 175 as white. And other thing, it is putting as black. See here. Here also in this black region, that means this intensity is lower than 125. That's why it has kept it as black. And other ones have the intensity above 125 and below 175. That's why it is white. So this is thresh. And in contours, we can use thresh too. I guess we can use thresh. Wait, let me check. See. Now, earlier we had some 360 number of contours. Now we are having 1569 number of contours in this thresh. Okay, where is this thresh? Ah, this is thresh and this is the contour. This is the contour for this thresh. The earlier one for was for canny underscore blur, and now this is for this thresh. See the grass. You can see the outlines of grass too, which is not good actually. That's why we use always canny and then put that canny into that into the input of the contours. So this is it for contours. I guess we can move to face detection. Any doubts? Type in the chat. Can you print out the length of contours? Maybe it's not detecting any contours. Oh, okay. Some code error is going on here. Okay. There shouldn't be
Karthik,
any code errors.
can you go through that and check if like the everything is being used correctly, because I cannot find any errors there.
Which one? The Joshua Jacob one.
Yeah.
Okay. Blank contours -1 0 0 255. Wait, contours minus my hierarchies CV dot data list. Okay, this is blocked actually. After CV dot data list, what is it? I hope so. It's correct.
It is
Okay.
CV dot chain approach symbol.
Okay. So what is the problem? You're not getting anything.
I'm not getting any output. It's just a blank screen when I CV
Okay,
dot
then
IM show contours.
are you getting an email? Are you getting an output for Canny?
Yes, I got all the other outputs, but this one didn't give any.
You
Oh,
put that R string
what are? Okay, I'm not getting what you're saying, but okay. And
before
I guess there are.
declaring the page. You put that R uh, string.
Okay. Yeah. So you're not putting that. Wait, what you're saying? Oh,
Karthik, screen. Okay, he's left the meeting. Internet issues. Sorry, guys. He will be back presently. Oh yeah, by the way, that R is just to remove the effect of the special characters. So I'm not really sure if that causes the issue. It should not cause an issue if there are no special characters, if you're able to open the image.
Also, guys, Karthik just rejoining in 2 minutes. He had a slight internet issue.
Yeah, while we're waiting for Karthik, how are you guys finding the assignments and sessions so far? You guys in message or unmute?
The optional questions are tricky, I think.
That's why they're optional. But yeah, it's I would encourage that you take the time to Google it, Google the relevant research material and stuff, because you will learn a lot while attempting the optional assignments. We try to structure this so that like you're not memorizing stuff. You have to do research and understand stuff to be able to do the assignments. So are the assignments like too easy or too hard, too lengthy, too boring?
Moderate, moderate.
Okay. Others, what do you guys
But
think?
optional
Will
one
you
is
guys in
hard.
message?
The optional one is hard.
Yeah, yeah. Other will you guys in message as well if you don't want to unmute. How many of you guys have programmed before this, like any language at all, not just Python? Maybe you guys can raise your hands. Okay, Java. Nice. C, Python, C++. I personally like C a lot. Okay, Joshua, I'll ask Karthik to send that code once he joins again. If you're still facing issues. Okay, C, C++, nice. In fact, C and C++ are very similar, right? So any valid C code would be C++, valid C++ code. Do you guys like Python, or what do you guys think about the syntax? What do you guys think about its libraries that we've done? Ooh, Kotlin.
Hello, hello. Sorry, sorry, guys.
Okay,
Extremely
okay.
sorry.
Uh, yeah, Karthik, just before you start teaching, Joshua has asked for the contours, a screenshot of the contours code. So if you could send that in chat.
Okay. Yeah, yeah, yeah. S- um, Chat. How do we add it? Attach file, I guess.
No, just control V, paste it.
Okay, just paste this. Okay. Oh,
Yeah.
okay. Yeah, guys, we have less time. I will complete the face detection part first. Sorry for that power cut. Face detection.py. For this, guys, pay attention for this. Go to Chrome. Go to Chrome. Everybody. Everybody, go to Chrome and then put har cascades uh face GitHub, something like this. But we'll get this first link. Guys, everyone, do this. GitHub OpenCV data har cascade at master, something like that will come. Open it.
Karthik, can you send the link in the chat?
Yeah, still if you I will. Okay.
Yep.
Here we have many data sets like eye, cat, see you can see frontal cat face, body, left eye, right eye, Russian plate number, and everything. Russian plate number, okay. And that all stuff. So we have frontal face default XML. Click this. I will share you this link. Uh, Copy. Where is it? Teams. Okay, sorry. Hmm. Teams.
Karthik, do you want them to download it?
Yeah, we have. No, we don't have to download it
Oh,
actually. We have to copy it. See,
okay.
this has some 30,300 lines. Just do Control A, Control C. What? Again, Control A and Control C. Okay, to copy everything. And then go to
No, no,
your,
no. Karthik, near the raw. You guys see
uh-huh,
near the raw, there's this square. No, no, go back to GitHub.
this one. Copy raw file.
Near the raw, there's this square thing. You can just press that to copy. Yeah.
Okay, still if you want to do it, you can Control A and Control C. That is also fine. No
Yeah,
problem.
you can do that.
Yeah, okay, okay. So yeah, now open another file. Name it as something like har cascades dot XML file. Put the extension as XML. Keep this in mind, and then copy and paste this.
Karthik,
Okay,
just a
you
minute,
have
your screen share is lagging a lot.
ah, okay.
Okay, yeah, I think now it is caught up.
Is it okay? Rishabh, is it okay?
Yeah, yeah, yeah.
Okay. Now you have created an XML file. Save this and go to your py file, face detection.py, and then start coding. Again, import CV to CV. Okay, wait, where I'm doing this. Sorry. Face detection.py. Huh. Import CV to CV and then write image is equals to cv.im read and take some good image like people like and there are some people you can see some faces. I will take some. I have okay wait I have here in my PC this PC downloads group to uh copy as path VS Code, paste it here, remove this, and put an R before it because we're using a complete data, like complete this path, and then cv dot im show uh group and image, and then cv dot wait key and 0. Control S and run. So see, I took this image, 5 faces we can see here. Now, what is our aim? We will put some boxes around this 5 faces. Using that XML file, we just copied, right? Everyone copied that XML file, right? Just put some thumbs up or put in chat, yes, we copied it or something like that. Uh, oh, hmm. Okay, today's day is bad. Okay, I'm traveling, guys. That's why I'm traveling right now. Okay. Huh. Tell bro. Everybody copied the XML file and pasted it like this. Har, cascades, or whatever the name you want to give. Dot XML you have to write. Make sure dot XML extension is there. Yes. Okay, I got first. Yes. Only one guy did that. Atish. Anyone else? I need at least 2 or 3 yes. It will be okay. Okay. Second
Karthik,
yes.
a bunch of them reacted with thumbs up, so
Oh, okay. Oh, okay. No problem. Okay. So now let's start. First, convert that image into gray. So for converting that image into gray, again, we are using CVT color. CVT, I'm going somewhat fast because I have to cover this. And then IMG CV dot color BGR to gray. And then you can show this. I don't want to show this. Har cascade, it's just a variable name. You can put it anything. And then use this function now. What is this function? Har cascade classifier. What is this har cascade classifier? It uses the data from that XML file that you have stored. Whatever XML file, be it faces, cats, dogs, animals, or anything, right? And then take copy this, copy relative path again, go to face detection.py and paste it here. That's it. And then faces, uh, boxes is equals to har. Sorry, spelling of har is HAR. Har cascade. Why Har cascade? We used here this same data type we have to use here. Okay, same variable name, sorry. Har cascade dot detect multi scale, not two, only multi scale. We will use gray here and put this as 1.1. What is this scale factor? I will explain you what is scale factor. First, let's see the output. Sorry, 1.1. And then we have some minimum neighbors, which we will mm, put as 3. Put as 3, I guess. Okay, I will explain you everything. Don't worry. And then print. Now, what is this print? Now, this faces boxes. What is this hard cascade doing is it is taking this gray image and we are putting some hyperparameters to it. What is this hyperparameters? It is the arguments. That's it. So the second hyperparameter is our minimum neighbors, which I set as 3. That means a particular person can have at most 3 neighbors around them. And this 1.1 scale factor, what is this 1.1 scale factor? It means that how many layers of people you have in your image. Like if someone is sitting in a class photo and there are some 3 or 4 layers, then you will say some this 1.1 means you are zooming the image to get the far row, like the farthest row of children. Like imagine this is the first children that are sitting, then this children are sitting behind them, then this children are sitting behind them. Now this row will be visible with 1.0. To make this row and this row visible, we use this as 1.2, 1.1, 1.3, 1.7. What is this 1.3, 1.7? We are zooming this picture to get this faces and this faces, or else it won't detect the faces that are far from the first row. Okay, that's it. And if number of faces and is equals to len. Why len? Because this faces boxes is a list that this function is returning us. Okay, so length and then faces underscore boxes. And that's it. Let's save this and run. I hope so. There are okay. Number of faces we are getting 7. See, but I guess there are 5 faces. Sorry, I guess there are 5 faces. Uh, it is detecting extra faces. Why? Let's see. Let's change this hyperparameters to 1 and try. Now number of faces 11. Damn. Okay. Let's use 2. Number of faces 7. To get this correct, keep changing the hyperparameters till you get 5. Okay, you can't put 0. Put this as 3. Number of faces 7. Okay, let's see what faces they are printing. Let's see what faces they're detecting. So for copy this, what I'm writing, X, Y, W, H in faces
Karthik,
underscore.
screen share is lagging a lot. Could you stop it and start again, maybe?
Oh, okay, okay, yeah. Mm-hmm. Okay, is it lagging? Uh, Keshav?
No, no. Yeah,
No,
it's
fine.
fine.
It's fine.
Okay, it was lagging from like 15 minutes or what?
I'm not sure, but I only realized when I saw you typing and it was not showing up. Like you were typing and we could not see
Okay,
it.
okay, sorry. Okay, yeah, so faces react. Make this for loop, guys, to print the boxes on that image. And let's see what 7 faces that the system is showing us. Now, CV dot, we are choosing rectangle as boxes. So CV dot rectangle. where we have to post these rectangles on image, obviously, and x comma y. Why x comma y? Because see, this faces and boxes is actually giving the coordinates, right? So the coordinates are x comma y. Now what is this w and h? It is width and height. So now what we will do is we will do x plus width, x plus width, sorry, x plus width, uh, x plus width and y plus h. We'll do like this. What is this? We are specifying 2 points of that rectangle. First is x comma y. Imagine this is a point, huh? This one. And then w plus h, width plus height. This is a rectangle that we are getting from this faces underscore boxes. This is what we are trying to do. Now 0, 255, 0. What is this color? Green. Okay. You can put it as blue, red, whatever you want. Thickness, sorry. Thickness is equals to 2. Okay. Now I have to show this, right? So CV dot, what we have done here is we are not using image dot copy. See this image dot copy we're not using, we are using just image. That means we are editing the image itself. So if we show, uh,
Uh, Karthik sir, it's lagging.
oh, okay, my voice is lagging or my screen is lagging or both are lagging.
Not
Yeah,
screen is lagging.
My screen is lagging. Okay,
yeah, guys.
no problem. It's no problem.
Please,
Like,
please give us a few minutes to sort this out. Uh, yeah, we'll till then
yeah, I will
please
type.
bear with us.
Yeah, yeah. Okay, are you able to see the CV.im show faces this
Yeah,
16th line of code?
you written that spaces. Yeah,
Yeah,
yeah.
okay. Okay.
Yeah, Karthik is visible.
Okay, thank you, Aryaman. So now I will go image. Why? Because we edited this image with this rectangle. Now let's run this and see if there are no errors, I guess. Okay. Okay, what are these 7 images? This 5 images and okay, this part is considered as image or what? Okay, I don't know. This is somewhat error that I'm getting here. This both are not image. Only this 5 are images. Still, this is better, right? This is okay. I will try to improve this. I will put this as I can put this as 5, I guess. Let's see. I should get something. Okay, now this guy is not coming as a face. Okay. Let's put as 4. Damn. Sorry. 5, 5, 5. Okay, we're almost close. We got some 6 faces, which is better. Okay, it's better. See, this 5 faces we are getting, right? This should be your output. Now try with your own images and do the following code. I had to teach actually this also. See, I had created this face recognition.py, then faces train.py, then also wanted to teach you this histogram and stuff. But okay, I don't have time now. Okay, first see this face detection, these guys. See this. Is it running for you guys? Is it okay? Okay, guys, is it really lagging right now? Like, is it okay? Keshav?
No, no, it's fine, Karthik.
It's okay
Oh,
only.
okay, it's fine now. Okay. Should I extend the session? Like more 20 minutes? I will teach them the facial recognition part if it possible. Can I? Okay, yep.
Yeah,
What
yeah.
is it? Yeah, okay, I can extend. Okay, then I will extend. Okay. I will not write the code. I will send you the code. You just copy it. See, I hope so you have completed this facial detection part. You don't have any doubts in this? Guys, just type yes. Yep, yep, okay. Okay.
Guys, the part after this would be optional. A part after
Hmm.
4. So,
Yeah,
if you have
actually.
any slot clashes with other sessions, you can feel free to look at the recordings.
Yeah,
Okay,
give
so
me
we'll
a minute.
continue with.
Like, give me a minute before you leave. I'll download the attendance now. Like, leave at 4 exact, okay? If you're going to leave.
If you have any doubts in this facial detection.py or anything, just type in the chat box.
Can you re-explain the line 10?
Line 10. Okay. Faces.boxes, hard cascade, detect multi-scale. See, what this function do is it takes this hard cascade this. It uses this data set that we have put here. Okay, not this one, sorry. This one. This is a data set actually, and it's coded in XML file. So it uses this and uses this gray image as a test data. And 1.1, what is the scale factor 1.1? As I explained, the row of children, right? There are three rows of children. And if we want the last row to be visible to that system, then we have to increase this 1.1 to 1.7, 1.9. Here we have only one single row. That's why this is the minimum number 1.1 I'm putting. Now, what is this file? This says that how many boxes of neighbors can you put? Like how many neighbors you have in your boxes. Like, wait, let me run this and show you. See, this is a particular box, right? So now it has two neighbors. This guy, this girl, and this guy, right? There are minimum neighbors two here. But now, as I wanted more number of boxes, that's why I increased this. If I put just two here, I will get something else. Let's see. Okay, VS Code is lagging for me too. Hmm. If I put two here, I'm getting this box also as an image, which is not actually. So this is an hyperparameter which you have to change. Okay, which you have to change to get a particular number of. Wait, sorry. Huh. Which you have to get change to get a particular number of images you want. Like there are five images, right? So try putting three, four, five, six as this minimum neighbors. We will at some point get particular five faces. I'm still getting six faces. So yeah, the hyperparameters I'm putting is wrong. You have to correct it using hidden and trial methods. So hidden trial is best for this. I guess I can move to this facial recognition part. See, for facial recognition, we have to create two files actually. Faces underscore train.py and face.recognition.py. First, faces underscore train.py. In this, we have to take a data set in which we have considerable amount of people in our directory. Imagine this is a directory I'm using. This is a path that I'm taking. I'm putting it as R because this is a raw path that I'm choosing. It's not a relative path, it's a complete path. And here there are five people in that particular folder, like A, B, C, D, E, or you can put as Karthik, Aryaman, Keshav, Asmita, like that. Okay. So this is the first thing you have to do, guys. And then you have to use this har cascade, har face or XML. Instead of har, use this. What is this? Copy relative path and then faces train, copy and paste it. This is our actual path for our har cascade.xml. Create this array for features and labels, and then create a function. This function I will explain. Okay, for person and people, we are creating a loop. Path is equals to os.path.join dir comma person. Now, what is this? In this directory, we are having five folders of five people A, B, C, D, E. So it will go in each of that folder and look for a person, right? So first it will go in A and take A as a person, and that person for a particular person, for that A person, it will go in another for loop which is for image in os.listdr path. what it will do is in that A folder, there are many photos of that A person, right? It will look into that. It will read that image into this image array. And then when the images are over, this statement will become true. Image array is none. And then it will continue. Continue means it will go to this line. It will move out of this if loop and move into gray is equals to cv.cvt color image array comma cv dot color is equal to bgr to gray. That is, it is converting that image to gray. And then we will put here as usual faces underscore rect or har cascade and this function. We will use this. Now, what is this for loop? It is different from our face detection.py. Why? Because we are using now features and labels here. Now, what is this features and labels? Here, we don't have to put just a box around the face, but we have to store the features of that image and also the label. The label is A, B, C, D, E. Now, what is this append label and append faces underscore ROI? It is calculating the features and storing it in features like features and labels. And then create underscore train. Using the particular amount of images that you have in that folder, it will train and then you will store your features and labels here. Features is equal to np.array features d type is equal to object. Why object? Because it's the image that is stored in the features in the form of array. And labels is just like label A, B, C, D, E. Okay, I guess
I
this is
think
too
Karan
long.
has
Okay.
asked you to explain cascade function.
Okay, which cascade function?
No, he has not understood what face detection from cascade is. So could you explain the concept?
Uh, which one? Karan, which one? This one?
Yeah, line number 8. CV dot cascade classifier.
Wait, line number 8. Okay, see what cascade classifier. See, this is taking the data set from this XML file. As I showed in this here, right? This is actually a data set of that images. This guy has taken some data set from internet or something and put boxes around it. Okay, and then converted into this XML file. Now, this function, what it does is it decodes this XML file and then trains this variable name from this XML file. Like now, when you put any image to it and it says some faces, then according to this XML file, it will put some boxes around that faces. So that's it. Cascade classifier is converting this XML file, decoding this XML file into this variable name. I guess that's clear. It is used to decode the XML file, and then we are using it here. Why? Because now we are testing it on this gray image, the gray image that we are taking from this image part, our group, a group image. So this is the training part. Wait, let me write here. Training, sorry, training part through .xml file, and this is the testing part through gray image of group. Okay, got it right, Karan?
Yeah, yeah.
Okay, okay, I guess. Should I continue for facial recognition or should I end it? If you have any more doubts.
I think you can go like 10 more minutes or so, something. It's optional anyways, and it's being recorded.
Okay, okay, no problem.
All right.
See, guys, I will send you the code. Don't write the code. Just understand for now. We are taking the features and labels here. We are cleaning this how through your directory, your folder directory that you have created, and you're putting the path as okay. Put some more amount of images so that your training is good, and also make sure when you train you have only a singular photo for A, B, C, D, E. It shouldn't be a group photo, it should be a solo photo. I don't have that now because it's a new laptop now. Okay. So train this first and then save all that training part in this features and labels. And then face recognizer, cv.face, or is this lbh face recognizer dot create. And what is this doing? It is creating a like a prompt type of thing such that we will now put features and labels, this input into this, and it will create this face recognizer, a function such that whenever we use this again, it will recognize the face irrespective of whatever file we are in. How? By saving this in face train.yml. Now, this is another extension to save the features and labels. Face underscore trained, it's a variable, it's a name just dot yml. So save it like this and also save the features and labels. After you save this, now you can use this face recognizer part anywhere in any of the folder. Okay, in VS Code on your system, obviously. So this is the faces.train. You have trained this face recognizer variable name, the face recognizer model. Now it's time to test it. Now to test it, we have another code now. Again, import numpy, import CV. Now har cascade. Again, we have to use this. We use this for detection also. These are the people. Okay. Let's convert into A, B, C, D, E so that it matches actually. Like this is A, this is B, this is C, sorry, this is D, and E. Like how many people are there in your gallery, in your folders? Put that amount of ABCD, whatever, and then use that face recognizer is equal to cv.face lb this create. Now again you are creating that prompt, but now we are not training it again. You will just read it from that file that you created in the train.py function. You created here and saved here, right? See, face.recognizer save so that you can use in another uh, files too. Now here you have just read the face recognizer. Image is equal to cv.im read. Now this is the training part. This was the okay, not training part. Training we have done in another file. So we are copying, sorry, copying the results from the training training.py. And now here we testing it, testing the model. Okay, what is this? John, okay, whatever it is. See, this now we are doing is we are taking another image which was not from your training data. This is something validation data. We call this as validation data to check the accuracy of your model. So now take a particular random image which wasn't in your gallery. Read this in a particular image variable name, convert the image into gray, and use this face rect this. What is this? This is converting, like this is putting the rectangle on that face. Okay. See. And then face labels confidence. Now this for loop is to detect is to use the results of that training.py on your test data, on your test image. What is this doing? Faces ROI is equals to gray, y colon y plus h, x colon x plus w. What is this? This is height h, this is w width. This is for the rectangle that I showed you earlier, right? In the face detection part. Wait, let me show you again. Face detection.py. See, x plus w and y plus h. This was for rectangle. So this is the rectangle that this faces underscore ROI is saving. In that in that faces.roi, it will now check the label and confidence. How? Using this face recognizer that we used here. See, face recognizer dot read and then dot predict faces underscore ROI. What is this faces underscore ROI? This is an array of that image that we got from this particular rectangle, right? It won't search for the entire image. It will just see the rectangle part because only the rectangle part has the face. So label, comma, confidence. What is confidence? It is accuracy. I will write here. Confidence is same as accuracy of your model. Okay. And then this is the print function, ref print. You're printing the label. Like what is your predicted label and what is your predicted confidence, what is the predicted accuracy. And then CV2 put text. See, I explained this in the first session, right? This part, CV dot put text. Now we are taking this string of people dot label, people bracket label, and putting a text on the rectangle. What is this Hershey dot complex? It's just a font, so I can use anything Hershey dot complex, simple, or anything. And then this is a rectangle that we are using. This is width, this is height, and in the end we are showing the detected face and image. Now this image will have the rectangle also, and also the text saying that what label you're giving, like what is your prediction, what is this image, is this A, B, C, D, or E. And here in the terminal section you will find the confidence, the accuracy also. So try this at your home and I hope it will work for you guys. Yeah, and try to use more number of images in your gallery. Now, for now, I don't have that gallery portion, so I can't run this. But try with your model, try with your gallery, try with your images. Any doubts here, guys?
Karthik, Pragyan, and Anika have sent out doubts in the chat. So
Okay. Again, Anika. Uh, Wait. Can you explain train function? Create train function. Okay. Create train function where in the faces train. Okay, this one. Okay. See, whoever asked this out, what function we are creating here? This function is to train your model. See, this directory, what is this directory pointing to? Now, see, this is the final folder, right? Train. Now, this train will consist, uh, this train should consist actually, should consist 5 folders of A, B, C, D, E people. Okay. And that folders should have the particular solo images of A, B, C, D, E. Now for person in people, path is equals to with path dot join dir comma person. This means that it is saying that in that dir file, in that train file, we are having 5 folders, and that 5 folders are like corresponding to the people, to the person. This A, B, C, D, E. The first folder is for A, second for B, and same way the last for E. Now for a particular folder, for a particular person, now another for loop will start. For each of that 5 folders, this for loop will start, and in that there will be some images, right? So that images, it will read as image array and save in this image array, and then it will convert it into gray. If there are no images in the folder, it will just do image array is none. This will become true and it will continue. Continue means it will get into next iteration of this for loop. What is the next iteration of this for loop? That is the next person. It will go for the next person because this person doesn't have any images. That's why I use this. So make sure you don't have empty images in any folder. Okay, convert this into gray, and then you're using this face rect, har cascade, detect multiscale. This is to create the rectangle, to create the coordinates of the rectangle and store it in this variable name faces underscore rect. And then here in faces underscore rect, what is this faces underscore rect? Your rectangle, your image. In that, you will record the features and labels through this function append label and append faces underscore ROI. And yes, after the training is done, you are saving it so that you can use it next time whenever you close VS Code. Yeah, that's it. This is the function create underscore train. Okay. And please explain. Okay. And what was next? Okay. Please explain path and list dr functions. Path and list dr functions. There are no functions like path and list dr, right? Okay. Okay. What is this doing? For image and os dot list dr means your directory. This directory. It refers to you have to go in this path. We have used this path is equals to os.path join dir person. That means it is going one by one into each of the folders A, B, C, D, E. When it joins to person one, that is dir.person. This when it the first for loop is going on, it is joining with the first folder. When the second for loop goes, it is joining with the second folder. That is, it is copying the path of the second folder in this path variable name. And that variable name, we are using it here. Why? Now, because we want to use it for images. For images, we will do this. So this function is just to like connect to the path, as you can say, like go to that part and search for images, search for folders, search for audio files, search for all that. This function is used everywhere, like even in your ML models and your CNN models everywhere. So like this is general function that you will use. Okay. Uh, explain path. Explain path. Path is a variable name. Okay. I think it's over, right? Keshav?
Yeah, we can end it.
Okay. Thank you, guys.
If
Thank
you
you
guys
guys
have
for having
doubts,
this.
today's session was rather confusing. If you guys have doubts, feel free to ask. If not, you guys can leave.
You can personally text me, no problem. Okay, my spelling is Kartik. It's not H. Please, guys, please. It's not Karthik. It's Karthik. Okay, no problem. I know, like this session was too fast because I wanted to complete the syllabus. That's why. Yeah, it's okay. Like I'm trained with this in IIT Madras. Everybody calls me
Double,
Karthik.
double spellings.
I think in South everybody's having Karthik. That's why. Okay, I guess we are done. I will send you this files. Do try in your folders with your images in your galleries. Try to search. I think there is a section in your this phone, right? People section, right, Keshav?
Sorry.
There is some people section in phone, right? In that peoples we get every photos of that person.
I am not sure. I do not use that if it exists. I
Oh,
think
bro.
Google
Okay.
does something like that. They will
Yeah, in Google's
combine.
photos. Yeah.
Google Photos. I think they take out photos according to who it is, and
Hmm.
I'm not sure if it's possible to access, but they do that.
Okay. In MI phones, we have access. Okay. No problem. Okay, then, guys. I'm stopping my screen. I hope it was a great session. And sorry for this fast teaching and stuff. Can you please summarize the face detection code once, please? Can you please summarize? Okay, okay. Face detection. Okay, detection. Okay, yeah. Okay, there's a face detection part. Mm, okay, see. Who asked this? Okay, leave it. Listen. First, we are taking the image of one particular image or group. We're converting into gray. We are taking this XML file. I sent you the link. Still, if you're not able to follow that link, try searching here. Arey yaar, sorry. Sorry. Try searching here har cascades GitHub. Okay. Faces GitHub, something like this. You will get the first link as like this one. This link. Go into this link. Go into default, frontal face default. Frontal face dot default XML, and then just use Control A, Control S. Sorry, not Control S. Sorry, Control A and Control C, or click on this copy raw file, and then go into VS Code, create this har cascades.xml, and save it here. Next, what you have to do is also save it here, and then not next what you have to do is write this function to train your file, train your part through .xml file. Put this copy path, your relative path here, and use this function cv.cascade classifier, which trains your har cascade with this data set. Now it's time to test your part through gray image of group. You have created this gray image, right? Now put this gray image into this input, har cascade detect multi-scale, put this input, and then print this. You will get something. I got here, I will show you the output. I got here this 6 people. This is an extra box I'm getting. Make sure you have only 5 and not 6 and not 7. How to do that? You have to play with this hyperparameters. What is this? This is a scale factor and this is minimum neighbors. Play with it and you will get the correct model according to your image. And then to put that image, you have to use this for x comma y, w comma h. What is this x comma y? X comma y means your coordinates and w comma h means your width and height. So to create a rectangle on your, the image, first you have to put is your coordinates, two coordinates, right? The diagonal coordinates, the top left corner and the bottom right corner, that diagonal coordinates. So x comma y and see, imagine this is x comma y, right? Plus w plus h. So these are the two diagonal coordinates. Make a rectangle. To make a rectangle, we are using this. We are making a rectangle on this image. So we will just show this image through cv.imshow function and then cv.weight key 0. I guess it's clear. I hope it's clear. Yeah. And why? Okay. Whoever asked this out, it's clear. Thank you. Okay. Any more doubts, guys? Guys, any more doubts? Okay. Vivek is saying thumbs up. Okay, no problem. I think it's okay. Okay, Keshav, I think we can end the session. Thank you guys for attending. Yeah. Give your feedback here or in the WhatsApp group or whatever, wherever you want to give.
All right, guys, we'll end the meeting now.
Okay, we will end the meeting. Okay. Already it's 4:30, right? 4:25. Okay, guys, bye. Thank you. This was my last session teaching you guys. Okay, bye. Okay.